Hey folks, ever heard of the Bermuda Triangle? Of course you have. It's that infamous region in the North Atlantic Ocean where ships and planes have mysteriously disappeared over the years, sparking countless theories and legends. But did you know there's another Bermuda Triangle in space? Yes, you heard that right. A cosmic counterpart to the maritime enigma. It's called the South Atlantic Anomaly, or SAA. This region is as intriguing as its oceanic namesake, if not more. Today, we're diving into this cosmic mystery. Buckle up, because this journey through space is going to be fascinating. So, what is the SAA? It's a region where the Earth's magnetic field is weaker than anywhere else on the planet. This anomaly is caused by the tilt of the Earth's magnetic axis, and the flow of molten metals within its core. One of the Van Allen radiation belts dips closer to the surface, right over the South Atlantic. This area bombards satellites and spacecraft with high levels of radiation, significantly higher than in other parts of Earth's orbit. Think of it as a cosmic Bermuda Triangle. But instead of swallowing ships and planes, it wreaks havoc on electronics and instruments in space. The SAA can cause serious problems for satellites and spacecraft passing through it. Electronics on spacecraft can go haywire, leading to data corruption, system malfunctions, and even complete shutdowns. Instruments can malfunction, and entire systems can shut down. Space missions have to be meticulously planned to avoid or minimize time spent in the SAA. Even the Hubble Space Telescope suspends its operations to protect its sensitive instruments when passing through this region. The International Space Station has had its fair share of troubles too. But don't panic. The crew is well prepared to handle these challenges. Space agencies are well aware of the SAA and have taken steps to mitigate its effects. They constantly monitor the region and adjust their operations accordingly. They design radiation-resistant electronics and carefully plan flight trajectories to minimize exposure. These measures ensure the safety and success of space missions. The term Bermuda Triangle first popped up in the mid-19th century, thanks to mysterious disappearances of ships and planes in the North Atlantic Ocean. Natural explanations like human error and bad weather make sense for those incidents. But the allure of a mysterious, dangerous zone has always captured the public's imagination. Fast forward to today, and we have the SAA, our Space Bermuda Triangle, sparking curiosity and scientific investigation. Researchers are constantly studying this region to understand its effects better. Unlike its maritime counterpart, the SAA has clear, scientific reasons behind its oddities. It's all about the interaction between Earth's magnetic field and the charged particles in space. This interaction creates a zone of intense radiation that can disrupt electronic systems. So there you have it, folks. The Bermuda Triangle of Space isn't a supernatural mystery but a fascinating scientific phenomenon. It's a reminder of how much we still have to learn about our universe. The next time you look up at the night sky, remember there's a region out there causing all sorts of headaches for our brave spacecraft. It's a testament to the challenges and wonders of space exploration. If you enjoyed this dive into cosmic mysteries, don't forget to like, subscribe, and hit that notification bell for more science adventures. Your support helps us bring you more exciting content. Thanks for watching, and keep exploring. The universe is full of mysteries waiting to be uncovered. Welcome back, space explorers! Now that we've navigated the cosmic Bermuda Triangle, it's time to delve deeper into another intriguing region of space, the Van Allen radiation belts. These belts are zones of energetic charged particles, most of which originate from the solar wind, that are captured by and held around our planet by Earth's magnetic field. Imagine the Earth surrounded by invisible layers of high-energy particles, like a protective cocoon. That's what the Van Allen belts are. There are two main belts, the inner belt and the outer belt. Let's break them down. The inner belt is closer to Earth and is primarily composed of protons. These protons are incredibly energetic and can pose a significant threat to satellites and astronauts. The outer belt, located further away, consists mainly of electrons. These high-energy electrons can cause serious damage to spacecraft electronics and even pose a radiation risk to humans in space. But how did we discover these belts? The Van Allen belts were first identified in 1958 by the Explorer 1 and Explorer 3 missions, led by Dr. James Van Allen. These missions marked a significant milestone in space science, revealing that our planet is surrounded by a dense band of charged particles. This discovery was crucial for our understanding of space weather and its impact on Earth. Now, you might wonder, why do these belts matter? Well, for one, they play a crucial role in protecting our planet from harmful solar radiation. However, They also pose challenges for space missions. Satellites passing through these belts can experience electronic malfunctions due to the intense radiation. This is why engineers have to design radiation-hardened electronics and carefully plan spacecraft trajectories to minimize exposure. For astronauts, the Van Allen belts are a significant concern. Prolonged exposure to the high levels of radiation within these belts can be harmful. This is why space agencies meticulously plan missions to minimize the time spent in these regions. The Apollo missions, for instance, had to navigate through the belts quickly to reduce the radiation risk to astronauts. In recent years, scientists have been studying these belts extensively to understand their dynamics better. The radiation belt storm probes, launched by NASA in 2012, have provided valuable insights into the behavior of these belts during solar storms. These studies are crucial for developing better strategies to protect our satellites and astronauts from radiation hazards. So there you have it, folks. The Van Allen radiation belts are a testament to the complex and dynamic environment of space. They are both a shield and a challenge, protecting us from solar radiation while posing risks to our space endeavors. As we continue to explore the cosmos, understanding these belts will be key to ensuring the safety and success of future missions. If you enjoyed this exploration of the Van Allen belts, don't forget to like, subscribe, and hit that notification bell for more fascinating insights into the mysteries of space. Thank you for joining us on this journey, and keep looking up. The universe has so much more to reveal. Welcome back, space explorers. Now that we've navigated the cosmic Bermuda Triangle and delved into the mysteries of the Van Allen radiation belts, it's time to take a closer look at another fascinating phenomenon: space weather. Space weather refers to the environmental conditions in space as influenced by the sun and the solar wind. Imagine a vast, invisible storm brewing in space, with solar winds and magnetic fields interacting to create a dynamic environment. These conditions can affect spaceborne and ground-based technological systems and can even pose a risk to human health. But what causes space weather? The primary driver is the sun. Solar flares, coronal mass ejections, and the constant stream of solar wind all contribute to the ever-changing space weather. When these solar events occur, they release massive amounts of energy and particles into space, creating disturbances that can travel all the way to Earth. The effects of space weather on Earth and space missions can be profound. For instance, solar storms can disrupt satellite communications, GPS signals, and power grids. High-energy particles from solar events can also pose a radiation risk to astronauts and even passengers on high-altitude flights. Additionally, space weather can cause beautiful but potentially damaging auroras, like the northern and southern lights. Scientists are constantly working to predict and mitigate the impacts of space weather. By monitoring the sun and its activity, they can provide early warnings of solar storms and other space weather events. This allows space agencies and industries to take protective measures, such as powering down sensitive equipment or adjusting satellite orbits to avoid the worst effects. One of the key tools in this effort is the Solar and Heliospheric Observatory, or SOHO, a joint mission by NASA and the European Space Agency. SOHO has been observing the sun since 1995, providing invaluable data on solar activity and helping to improve our understanding of space weather. In recent years, new missions like the Parker Solar Probe and the Solar Orbiter have taken us even closer to the sun, providing unprecedented insights into the mechanisms driving space weather. These missions are crucial for developing better strategies to protect our technology and ensure the safety of astronauts and Earth-based systems. So, as we continue our journey through the cosmos, it's clear that understanding space weather is essential. The sun's influence extends far beyond its light and heat, shaping the environment of space and impacting our technological world. If you enjoyed this exploration of space weather, don't forget to like, subscribe, and hit that notification bell for more fascinating insights into the mysteries of space. Thank you for joining us on this journey, and keep looking up. The universe has so much